Hello everyone, my name is Thiara Ortiz. I am the Cloud Gaming SRE Manager at Netflix, and I'm really excited to be talking to you today about managing black box systems. In today's talk, I'm looking to establish a foundational model that helps you think through how to manage these systems. And I'm also going to be sharing 3 case studies of observability wins that I've seen throughout my career. And we're here at Dublin for SREcon EMEA 2025, and I want to start our conversation about managing black boxes by going back 800 years to a castle that you can visit and is just a few kilometers from here. Dublin Castle was founded in 1204 as a Norman stronghold. It was built understood that something so fundamental, that no single line of defense was going to be perfect. You could have the moat be drained, the walls could be breached, the gatehouse could be broken, and towers could fall. But they built it anyway with multiple layers of defense because each layer didn't have to be perfect. It just allowed us to have additional time. It provided visibility and gave defenders a chance to respond. Ultimately, this is very similar to the kinds of challenges we face today as SREs as we manage these black box systems. We can't have complete visibility into every single component that we're responsible for, but we can build layers that buy us something invaluable, which is time. So today, I'm hoping to share you a framework that helps guide you through these black boxes. So what is a black box? A black box is a complex system or device whose inner workings are not readily understood. And here's a few examples of black boxes that you may be hearing about today. So you have LLMs, because these are large language models, and you actually don't know what's happening underneath the hood when you're interacting with one of these GPTs. There are general expectations about what you have to be a good response from interacting with one of these models, but there's not anything that's guaranteed beyond an HTTP status code. We also have games executable, which is near and dear to me as a cloud gaming SRE manager. Having come from a world where I was managing the Netflix CDN and we were serving static video files, moving to a world where we're supporting games executables, which are fundamentally black boxes in their own, provides an additional opportunity for us to learn how to manage them. We also have external APIs and integration. So many of you in the audience today may be managing systems that allow for people to be purchasing items online, and you may delegate that to a third-party vendor that performs the transactions. You don't have visibility on whether they're implementing a migration that could impact their overall availability. And for the most part, you just need to trust that when you execute a transaction, that everything will be okay. And then the last example that I have here is vendor appliances and hardware. So many of us in the audience here may be relying on cloud compute offerings. And while they have high levels of availability, you actually don't know which individual server your services are running on. It's possible that that one server has had multiple repairs and is being considered as a lemon or underperforming. So when it comes to being an SRE, we need to pick our battles to determine what we want to better understand and manage, because it's not feasible for us to try to understand the full stack. How many of you in the audience here today would say you're having to be responsible for a component of the black box system? Raise your hand. So like a majority of the room here. And for many of us, we're responsible for supporting a platform that runs these black box systems. These black boxes can be multiple different applications that you don't have full visibility into. They can be running on shared resources or have noisy neighbor issues. Additionally, there can be opaque changes that happen outside of your platform. And oftentimes, when there's an incident or something goes wrong, the platform is the first to be blamed. These changes are fundamentally opaque because they could be happening externally to you. For example, you may have some third-party dependencies that are being modified that you're not even familiar with. And in the example of supporting cloud games at Netflix, one of the things that I've seen is we support the physical infrastructure in which we're running these executables, but we allow the game developers to have flexibility in modifying their games on the fly. So we may want to allow for them to enable some seasonality changes so that when you play the game and it's Halloween time, it has some sort of Halloween visual. Fundamentally, these are all happening outside of our visibility as SREs, and so we need to figure out how to be managing them. And then the other thing that's immediately top of mind for me is for A/B testing. Netflix is highly well known for allowing our employees to run A/B tests to see how things are performing in the wild. But if there's an A/B test running and there's some overall changes happening on our platform, it's really hard for us to correlate what's changed if we are not making them ourselves. Ultimately, we need to figure out a scalable solution for managing our fleet of black boxes, and that's going to be the fundamental truth for all of this, is we're going to need to build a strong framework that allows for us to handle multiple black boxes rather than just dealing with an individual one. And then lastly, what's really important for all of us in this room here today is to communicate the challenges that we're dealing with our leadership teams. So without them being aware of some of the complexities that we have to deal with on a day-to-day, they might not understand why the system isn't as reliable as maybe some of our historical systems have been. And with that, let's talk about the modern reality that we're gonna live in. And there's not going to be a single solution, as I mentioned with the Dublin Castle. There's going to be a layered approach when it comes to this. And we can begin by gray boxing where possible. So I mentioned black boxes are systems where the internals are not readily understood. Gray boxing allows for us to better understand our systems by investing time and resources. We can use this as an opportunity to define where there are black boxes that exist because we haven't had the resources. So an example of this is if I were to ask you all, how does Netflix streaming work? You may just think it's as trivial as you have a user, some black box wizardry, and then streaming happens. But with some additional time and resources, you can better begin to model the dependencies that you have. So here's actually a diagram about how Netflix streaming actually works. This does mean that you need to spend cycles to understand your full end-to-end dependencies here. And even when I've drawn out this diagram, there are still components that are shown literally in a black box. So let me dive into the cache control service, which is shown on the bottom right. The cache control service is responsible for receiving information from all of our OpenConnect appliances on a periodic basis. It's our way of knowing what are the available files that are currently on our OpenConnect appliances, what is the health status, and what are the routability clients that we can reach from them. Given that we know that this is such a critical component to the user journey, we should really invest our time in ensuring that we have strong fundamental alerting and monitoring around this particular system. So if we were seeing that clients, when they were trying to play back some pieces of content, was failing to begin, and we see errors happening related to the cache control service, it would be relatively easy for us to correlate the two. But this isn't to say that everything can be gray boxed. It's not feasible for us to spend all of our resources to build this kind of model for everything. So with some preliminary gray box work being done, we need to ensure that we have a strong foundation of alerts that we can rely on. And these are table stake methodologies around maintaining and managing our services. I recently learned that table stakes is actually a term that comes from playing poker. It's the minimum amount of money that you need to bring to the table. So think of this as like the minimum amount of metrics that you need to have to be successful in managing these black boxes. Starting on the left, we have the use method, which is intended for performance-based monitoring. The U stands for utilization, so how much of a resource is being used. The S stands for saturation, how much of the work is waiting to be done. And E is the errors, what is the count of errors. It allows for us to identify performance bottlenecks and issues within your systems. We also have the red method, which is built for looking at microservices. The R in red stands for the number of requests, or RPS. E is the errors being reported by your service. D is the duration. We also have our critical user journey metrics. So if we were going back to our Netflix, like all of our dependencies that make up Netflix streaming, these would be metrics that are specific to our application. And it particularly focuses on the end-to-end metrics. And then lastly, I'm going to have to lay out the bad news here. We're going to have tailored metrics specifically for our black boxes. So despite having a black box and you don't know the internals of it, we're going to have to enable some metrics to track them. So let's look at a few examples of what these metrics might look like. So for the use method, we can track utilization over time. And let's say that we're supporting a platform that runs multiple different applications, and we don't know the internals of them. We can use the use method to track the system resource and determine whether there's a baseline that we can compare against. And if there's not a baseline, ideally there's some sort of contractual agreement specifying the limits of this particular application, a contract, if you will. And in this example, which I've mocked up by Claude, it's showing what the theoretical RAM usage is across multiple different applications. As you can see, there's one that clearly is standing beyond the rest, and it's possible that this particular application will start cannibalizing some of their system resources. And so we need to be monitoring this, and in the most egregious cases, we need to prevent the cannibalization. Now for the red method, so focusing on a single application, we would want to look at something like the duration metric. So this diagram on the left-hand side here is showing the overall distribution of duration metrics for a particular application. And again, you can kind of see that something has changed in the middle of September that's caused the overall duration metrics to increase. So we want our strong use and red alerts so that we know when something is not working or potentially has issues. And we also want our critical user journey metrics to tie the whole end-to-end picture. It's intended to capture all of our dependencies. So if we were going back to the Netflix streaming example, the way I would think about our critical user journey metric would be for any client that attempted to play a particular piece of content, were they able to successfully receive URLs and play from an Open Connect appliance? That would be considered a successful session. And from that, we should be able to track that over time. So on the right-hand side, we have % of successful video streams over time. And it's very clear that something has degraded on a particular day. I think it's 9/14. And this gives us an indication that there's something along our dependencies that isn't working quite correctly. If we were talking about like an application such as an LLM, what our critical user journey metric might look like is for anyone who goes to the chat website, are they able to input a prompt and receive a non-zero length response? And so for these particular metrics, you really need to think about your particular application and what those end-to-end metrics should be. So the next one is tailoring metrics specifically around our black box use case. So we need to think about the application itself and then determine which metrics fit it best. So are you responsible for deploying a machine learning model that gets deployed into a customer-facing application? Are you managing streaming content that's being delivered from a third party? Or are you responsible for some sort of service that depends on a third-party interaction? And then the key here is to determine what metrics would allow for you to determine whether things are working properly. So in the case of cloud gaming at Netflix, one of the things that we would want to look at is something like the play duration per title. And this allows for us to have one common metric that tracks all of the different games without having to be completely aware of what these individual games are. So again, mocked up by Claude, this is looking at a bird's eye view of what's happening on the platform. You can see here there's something happening on, again, September 14th that's caused 2 titles to degrade in their average play duration. Now with this particular piece of information, we should be able to determine what exactly has changed. Is it possible that someone enabled a A/B feature that's incompatible with these particular titles? Maybe they're testing new resolutions and frame rates. Additionally, if we identify that these 2 titles correspond to the same game developer, it's possible that there's some third-party dependency that is not functioning properly. So to recap, there's not going to be a single solution. We need to apply this layered approach where we're looking at our fundamental metrics. So the use method, the red, the critical user journey, and our specific tailored black box. And furthermore, we need to embrace a world where we have a layered system of defense. So going back to our Dublin Castle, it's not feasible that we're going to have all of the metrics and alerting and monitoring to prevent every failure from being shown on our platform. But we need to enable these strong foundational alerts to prevent these regressions from being introduced. So when we've defined these metrics, instrument them as part of your canaries to prevent these changes from going out. In addition to that, we know we're not going to catch everything. So let's work on building out a strong defense system so that you can detect when these issues have gone into the wild. Configure alerting across your metrics and leverage incidents as a way to close this feedback loop here. So if you find a new incident, which particular metrics point you to that particular problem? Can we add it to our prevention and detection steps? And then lastly, we need to have strong mitigation strategies. So in a world with black boxes, we're going to need to be really agile, and we need to have runbooks around our mitigation strategy. We need to have tested rollback mechanisms and ways to hotfix forward if needed. We need to be agile in this new world. And with that, let me share specific case studies for how this looks like in production. So earlier this year, we published a blog talking about the content delivery efficiency at Netflix, and I want to dive into one of these tailored black box metrics. But to set the stage, the CDN SRE team is responsible for managing over 18,000 of our OpenConnect appliances in over 175 different countries. These OCAs have content pre-positioned on them, so the night before a particular title is released, we will push that content onto these servers. What this means is that each individual OCA is continuously looking for the latest files that offload and localize the traffic the most at these locations. And when you think about a single title, it's not like a single, one file. It's actually made up of multiple files. So if we were looking at The Crown Season 1, Episode 5, you have your video tracks, audio tracks, and subtitles. So to determine what content we should populate, we need to figure out what's the popularity of all of these pieces of content and how should they be best placed on our machines. And to do this, we have our black box. We have a popularity prediction black box. This particular machine learning model takes in historical data about what people are viewing on Netflix, what particular titles may be popular and coming onto the platform, and we look at the bitrate streamed by our members. It takes all of this information and then determines what files a specific OCA should download. So as you can imagine, for us to build some alerting around title predictions, it would be really, really complicated, especially because we're not trying to get 100% perfect with title prediction, we're just trying to minimize how much traffic is sent further away. So rather than us trying to ensure that each title is perfectly predicted, what we have built are metrics around instances where our clients are trying to view pieces of content that are not available locally. And that's called content shed. And it's talked a lot in the article if you're interested in more. But fundamentally, what this is when requests are served from an OCA, not from the nearest OCA because the content isn't available on it. We are able to track this by logging this data at steering time and attribute the streamed client traffic to it. So now we know, hey, this is the amount of traffic that was not streamed from these servers because of popularity. So from this, we get a much clearer picture about how well our prediction algorithms are performing in the wild. When we see alerts trigger for content shed, so in this example, 1, 2, 3, 4, 5, 6, we can attribute that to traffic that was streamed from non-optimal locations. In addition, we also know which exact piece of content that is. So in this particular case, this content shed is being driven by a single encode and a single piece of content that we mispredicted popularity for. As the SRE teams were able to automatically deploy these on the servers to minimize the user impact. But in all of this, we needed to develop specific metrics that are tailored to this use case. And we needed to work with our machine learning partners to improve this model when we identified regressions or even significant content miss. And that goes back to tailoring these individual black box metrics. Now for case study number 2, which I will call benchmarking hardware to detect unknown unknowns. So I'd say that black boxes are everywhere, and I'd even consider the hardware platform that you specifically own to be a black box when you're operating as a hyperscale. Seemingly identical servers aren't actually identical. And let me talk about why. So first, you have what I would call the silicon lottery. The individual components that go into these servers are being manufactured at different points of time. There could have been a regression at a manufacturing site which resulted in different batches of components behaving differently. So even though they're supposed to be identical, they're not quite. Additionally, if you're shipping different hardware over extended periods of time, you're going to end up with firmware fragmentation, where multiple different firmware revisions out in production have different behavioral deltas. We also have configuration drift. So on the servers themselves, while they're running in production, you can have them changing over time. So PCIe lane training can be trained to different widths and speed after transient failures, which could result in, again, identical servers behaving very differently. And then this is what I would call the statistical inevitability. So when you're operating at a scale of over 1 million servers, your 1 in a million sort of errors, the ones where you have a bad capacitor, a memory flip, you have these really rare events, they're actually not so rare anymore. So what do we do in these particular cases where we have a fleet of identical servers with unpredicted variance? So we start establishing a baseline for hardware performance. And this is our example of tailoring a black box metric for this. So the challenge is, how do you know if quote unquote identical hardware is actually performing identically? So internally referred to as Lemonade and publicly mentioned as Fleet Scanner by Meta, we were able to benchmark servers in production to standardize and build a library of expected performance. By doing this, we could compare identical servers against one another and identify underperforming machines before they hit production. So to do this, we needed to run several different kinds of benchmarks and measure everything. We had to build a reference library. So I've shown here, there's a normal distribution for a CPU benchmark. And that's our reference library. And then from all of this, we need to hunt for lemons or underperforming servers. And so if we were to benchmark a machine that is severely underperforming the CPU benchmark, we could identify it as a lemon before it goes on to production. All right, so I've talked about several different kinds of frameworks for monitoring, and then the last one that I want to talk about is leveraging consumer insights. So something that I've learned even more so as I've had the opportunity to work on a platform that manages to run black box executables is the importance of leveraging consumer insights, because our user feedback ultimately is telemetry. So here's an example of how you could potentially use that. So what you would want to think about is, what would your users do when things aren't working properly? If you're trying to stream Netflix and you're unable to fetch critical assets to start up your device will show you an NW2-5. Now, Netflix publishes a help article that's public facing that our members can look at. And what we can do is track the frequency at which people are looking at this particular article to detect whether there are any regressions. Now, in this particular case, we actually do track client-side errors, and we do know about this, but if there was an instance where we didn't, we could leverage additional secondary signals to understand what's going on. And here, something seems a little off, where we have an increase in the number of people looking up this article. Okay. And then when it comes, again, to true black box systems, it's not always possible for us to identify exactly what's changed, but we could leverage something like survey responses to track user sentiment over time. So if you are as fortunate as I am, you have people who provide feedback on your service, and they will rate it between 1 through 5. You can track this over time and see how proportions of feedback changes. And in this particular case, it seems, again, 9, 14, something has regressed, and we see a reduction in our 5-star ratings. We want to enable canaries to monitor when user sentiment around our services are changing, and if you don't have access to a survey that's rating between 1 through 5, you may be able to leverage something like the thumbs up and thumbs down ratios. With this data, we can start tracking and alerting on different kinds of dimensions. We may be looking at if this is impacting a single title, if it's only happening in an individual country, a device group, or even more granular in ASN. And then tying in even more with some feedback that we get from our members, if you're ever as lucky to receive free-form feedback, we can leverage LLMs to better classify these kinds of feedback. So this particular one says the video quality was a little choppy and looked like it was running on 720p. It reminds me of streaming a game from another computer, which is really funny because this is for cloud gaming. So this piece of feedback I got from someone. By leveraging an LLM, we're able to bucket these kinds of feedbacks into different groups. So in this particular case, we could classify this as a piece of feedback associated to quality of experience. And by doing this, we can start tracking buckets of feedback over time to see if there's any changes on our platform. Ultimately, we're not fixed in the buckets that we've established, and so if we're learning new things while managing the service, we can modify the buckets. Now, with all of these new metrics, we need to ensure that we're not drowning in a sea of a million alarms blaring at you. And this is where I'd say we would adopt composite metrics or alerts. So rather than alerting on reduced engagement, increased complaints and surveys, and increased searches for help articles, we would bubble this up as user satisfaction diminished. So if that alert triggers, you have all of these secondary signals to look at. And with that, I'm going to share the last case study that I have. So how we continuously improve the reliability of our platform. So back in 2024, we had noticed that despite any of our core KPI alerts firing, then a manual audit of the free-formed feedback showed that there was a potential regression. So it's not exactly this, but the distribution looked pretty similar, where over time, we were seeing a gradual increase in the number of feedback associated with quality of experience. And by diving into those explicit pieces of feedback, it was very clear that there was something wrong. So in Spanish, these first two says, the game does not charge, the game does not appear, and then the last two are showing the game will not load. This was pretty telling that there was something wrong in our platform. And what we were easily able to correlate this with was we had just finished a deployment of all of our server firmware. And so one of the challenges in all of this, however, is that when we deployed this change, this was only impacting a subset of users on their first time engaging with this particular title. So it made it a little bit tricky for us to identify. So what do we do from this, and how do we continue leveraging these metrics? At Netflix, we leverage incidents as opportunities to learn, and we embrace these lessons as they teach us where there are gaps in our observability, monitoring, and resilience. When we looked closer at the specific root cause, what we had found is that there was a specific exception string that was being reported that was correlated with these users receiving a black screen. So shown here as Netflix exception, NGP profiles response type name unknown. And you might think, oh, I should alert on this particular string. But no, we shouldn't, because by the time we identified this regression, we worked directly with the game developer to fix this particular issue. And so we're not in the business of playing whack-a-mole where we're trying to find individual exception strings and alert on them. We needed to figure out a scalable solution that applies to multiple titles. So what did we do? Well, the first thing that we did was we enabled alerting around user sentiment and user behavior changes around our titles, rather than just relying on our core KPIs. We also instrumented these metrics into our canaries. So going back to that prevention stage, we wanted to harden that to prevent us from releasing new firmware that impacted particular titles in production. What we did as well is we developed correlations between these exception logs and user behavior. So we were able to correlate which exceptions were highly correlated with people quitting the game. And that allows for us to build a scalable way of alerting on unique exceptions that are performance impacting, rather than alerting on individual strings. We also implemented low complexity and black frame detection on our servers to be applied to all games moving forward. So this is yet another way of building another tailored metric for our black box. And we needed to adopt mechanisms for reducing member harm. So when we identified this happening in production, we needed to figure out how do we fix this as soon as possible. And we also learned about closing the feedback loop. So throughout this incident, we were working really closely with the game developers, and we're working in tandem, highlighting the challenges in observability, monitoring, and resilience, and we're able to get everyone on the same page. So this was an incredibly critical part of this particular incident. And with that, we get into accepting the new reality, which is that we need to fundamentally adapt. So here's what I want you to take home. We're going to continue managing black box systems, and we'll likely be managing even more of them in the future. There's not one signal that's going to be enough for everything. So not the user error rates, not the latency, not even the user feedback. You need multiple independent sources that correlate together that tell you a picture of what's happening. Correlate across all of your layers, because one signal can look like noise, but three pointing at the same thing is clearly an incident or a problem. Invest in your detection systems. So the Dublin Castle survived 800 years, not by being perfect, but by being resilient through redundancy. So think about your systems in the same way, because when black boxes fail, and they will, you need more than hope and dashboards, you need layers. Thank you.